Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular paper is Edexcel 2021, Paper 1, Higher Tier. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I've recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below, as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends, because they might need a helping hand too. Okay, let's get into it. Welcome along to another past paper walkthrough. Generally there's two paper sets each year, so there'll be a June set and a November set. This paper would have been originally prepared for June 2021, but then the exams got cancelled, and so it is now listed on Edexcel's website as November 2021. But there's only one paper from 2021, so if it's got 2021 written anywhere on it, it's the same one as this. Right, let's get cracking. Question 1. Work out 3.67 times 4.2. Presumably you know how to do column multiplication. This is the non-calculated paper, so you need to have a decent way of multiplying, don't you? Okay, so 7 2s are 14, carry 1. 6 2s are 12, plus 1 is 13, carry 1. 3 2s are 6, plus 1 is 7. And then next row, 4 7s are 28, so 8 carry 2. 6 4s are 24, plus 2 is 26, so 6 carry 2. 3 4s are 12, plus 2 is 14, so 14. There we go. And then adding it up, 4 and 0 make 4, 3 and 8 make 11, so that's 1 carry 1. 6 and 7 make 13, plus 1 is 14, that's going to be 5. And there we go, 1 5 4 1 4. Okay, but remember we've got how many decimal points in the question? We've got 1 2 3 appearing there after the decimal point in the question. So we're going to have 1 2 3 appearing after the decimal point in the answer. So it's going to be 15.414. If you're not sure you got the decimal point in the right place, just round the numbers off and multiply them and get a feel for the size of the number. So like rounding those off, it's 4 times 4 is 16, isn't it? So it's of the right sort of magnitude. So part B, we've got 59.84 divided by 1.6. So we're going to be dividing by a decimal. I don't really like that, really, to be honest. I'm going to just times top and bottom by 10, I think, to get rid of that that decimal there for the divisor. So if I multiply both parts by 10, we're going to be dividing one by the other anyway. So if I scale up the top and the bottom by a factor of 10, it's a bit like writing an equivalent fraction down, isn't it? It doesn't change the value. So that would be 598.4 divided by 16. So 16 is my divisor into 598.4. So 16s into 5 don't go. 16s into 59. So what's that? That's 16, 32, 48 and over, is it? 48, 58, 60. Next one would be 64, which is too much. So it goes in 3 times. So 3 16s are 48. That's the remainder of 11, isn't it? So I'm going to squeeze in 11 there. So then 16's into 118. I'm going to have a few more on my list, aren't I? So 64 is 18x, then 96, 100 and what's that? 112. One more? No, one more would go over, wouldn't it? So the next one would be 128, which would be one too many. So what's that? 1, 2, 3, 4, 5, 6, 7 times. So that goes in 7 times. So 16 times 7 is 112. So that gives me a remainder of 6 this time, doesn't it? So the 6 goes there. And then 16 into 64 we can see is there. It's 4 times, isn't it? Okay, decimal point is here. It's going to be here in the same point in my answer. It's going to be 37.4. Question 2, we've got a Venn diagram here, and we're asked to complete the Venn diagram for this information. The information is up here. I've got E, the universal set. That's equal to even numbers less than 19. I'm just gonna list those out quickly. It won't take me very long. Even numbers less than 19. So that's 2, 4, 6, 8, 10, 12, 14, 16, and 18, isn't it? So that's that set there. They're the values that are, they're all the values that are going to be on this diagram. Now, some of them are going to be inside these circles. Okay, taking a look at sets A and B, you can see that they've got 2 elements in common, haven't they? I've got a 6 that's in both, and an 18 that's in both. Okay, so those 2 elements belong in the center, in the intersection of these 2 sets. So the 6 belongs here, and the 18 belongs in the middle as well. Okay, now I've got one number left over in the set A. Okay, so that's going to have to go here. Look, so inside set A, but outside the intersection. And then with B, I've got 2 and 14, so they belong inside set B, but not in the intersection, so 2 and 14 belong here. Okay, now I haven't quite finished yet because my universal set has got all those numbers here, and I've only got a few of them down. So let's just go through and tick off the ones we already had. So we had 6 and 18 in the middle, didn't we? And then we had 12 in the left-hand set, and then we had 2 and 14 in the right-hand set. So then these ones that are left over then need to go outside those 2 sets. So 4, 8, 10 we haven't had yet, and 16. So they belong inside the universal set, but outside set A and B. Okay, just gonna double check I've got the same number. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it all matches up. Good, let's move on. Question 3, work out 4 1/5 minus 2 2/3. Give your answer as a mixed number. Okay, well, they're already mixed numbers, aren't they? But they're not super easy to add up when they're mixed numbers like that. So probably the easiest thing is to convert them both into top-heavy fractions, then find a common denominator, then do the subtraction, and then convert them all back again. Okay, so let's take the first one, 4 1/5. Now, to convert it into an improper fraction, what we do is we multiply those two together, the whole number with the denominator, and then we add on the numerator, don't we? So 4 times 5 is 20 plus 1 is 21. So 4 1/5 is the same thing as 21 over 5. Okay, let's do the same thing with the other one. So we've got 2 and 3 there. So 2 times 3 is 6. And then add on that one there, it gives me 8. So that makes 2 2/3 the same thing as 8/3. So minus 8/3. Okay, we're making progress. Okay, next step is to find a common denominator, isn't it? Now, the lowest common multiple of 5 and 3 is going to be 15. So I'm going to make these as fractions over 15. How many times does 5 go into 15? It goes in 3 times. So multiply top and bottom by 3. That's going to make 63 out of 15, or over 15. So 63/15. How many times does 3 go into 15? It goes in 5 times. So multiplying top and bottom by 5. 8 times 5 is 40. So that's the same thing as 40/15. Okay. Right, now we're cooking on gas. Right, so what's going on here now? I've got two numbers with the same denominator. So if I want to subtract them, then I just subtract the numerators then, don't I? So 63 minus 40, that is 23. So 23/15. Are we done? Not quite, because the answer says, well, the question says, can you give it to me as a mixed number? This is not a mixed number. This is still a top-heavy fraction. So how many times does 15 go into 23? 15 goes into 23 once. Remainder 8. So that's 1 and 8/15 as a top as a mixed number then, isn't it? So 1 and 8/15. Final answer. Question 4. At the end of 2017, the value of Tamara's house was £220,000, and the value of Rahim's house was £160,000. At the end of 2019, the value of Tamara's house has decreased by 20%, and the value of Rahim's house has increased by 30%. At the end of 2019, whose house had the greater value? You must show how you got your answers. Okay. Now this is the non-calculated paper, so I'm going to use a non-calculator approach. I'm going to start off with Tamara's house. Let's start with Tamara. So Tamara. Now 100% of the value of her house was 220,000 then, wasn't it? Now I want to work out what I want to do a 20% decrease. In other words, I need to find out what 20% is and then take it away, don't I? So what's 10%? 10% is going to be that amount divided by 10. So, or kind of scratching a 0 off the end. That's going to be £22,000 then, isn't it? So then 20% is going to be twice that. That's going to be £40,000. Okay, £44,000, sorry. So then if I want to find 80%, I want to then take my 100% and I want to minus that there then, don't I? I want to take that away. Okay, so what is, so 100% take away 20% is 80%, and 220,000 minus 44,000, so 220 take away 44, and we'll take away 40 would take me down to 180, take away another 4 is 176, isn't it? So that's £176,000. Okay, so that's Tamara's. Let's have a look at Rahim's situation. He's doing rather well. His is going up, isn't it? So his started out at £160,000. Okay, so then we're going to do a similar approach. Let's find 10% first. 10% is going to be £16,000 then. So then 30% is going to be 3 lots of 16,000. 16, 32, 48,000, isn't it? Okay, his house has gone up a lot. So then 100% plus 30%, what's that then? That's going to give me 130% here, and 160,000 plus 48,000. 160 plus 40 is 2,000. Is 200, sorry, plus another 8 is 208. 208,000. Okay. So let's answer the question: whose house had the greater value? Rahim's house greater, and then we're just going to say that 208,000 is bigger than 176,000. Okay. Question 5. Rosie, Matilda and Ibrahim collect stickers. And I've got a ratio here. It says the number of stickers Rosie has to the number of stickers Matilda has to the number of stickers Ibrahim has are in the ratio of 4 to 7 to 15. Now, Ibrahim has 24 more stickers than Matilda. Ibrahim has more stickers than Rosie. How many more? So let's have a look at these ratios. We've got Rosie to Matilda to Ibrahim, and they are in the ratio of 4 to 7 to 15. Now, I don't know how many stickers Matilda had, but I do know that Ibrahim had 24 more. Okay, so I'm just going to draw a quick bar model to think about this. Okay, so I'm just going to draw a quick bar model. So let's divide it up. So Remember, Rosie has 4, Matilda has 7, and Ibrahim has 14. That's the kind of ratio. It doesn't mean that's how many stickers they've got. That's the ratio that their stickers are in. Okay, what I'm going to do is I want to just compare Matilda's and Ibrahim's bar. Okay, so this bar here is worth 7, wasn't it? Okay, now if I pick that up and move it over here next to Ibrahim's, so we can see that if Matilda has 7 stickers for every 15 stickers Ibrahim has, then that kind of means that Ibrahim has an extra 8 stickers for every an extra 8 stickers compared to every 7 that that Matilda has, doesn't he? So that's going to be 8 in there. But we're told that actually Ibrahim has 24 more stickers. So those 8 shares there are actually worth 24 stickers. Okay, so those 8 shares are worth 24 stickers. So then what is each share worth then? Then each share then is going to be worth 3 stickers. So 1 share equals 3 stickers then. Does that make sense? So then if 1 share is 3 stickers, then this one here is going to be worth 21 stickers, or 21 here. Ibrahim's going to have 15 lots of 3. He's going to have 45 stickers altogether. And Rosie's going to have 4 times 3. She's going to have 12 stickers to start with. Okay, so if Ibrahim has got 45 stickers and Rosie has 12 stickers, how many more does Ibrahim have? Then Ibrahim has 45 stickers minus 12 stickers. He's going to have 33 more stickers compared to Rosie then, isn't he? So Ibrahim has 33 more stickers than Rosie. Question 6. The diagram shows a prism. The cross section of the prism is a right angled triangle. The base of the triangle has a length of 5 centimeters. The prism has a length of 25 centimeters. The prism has a volume of 750 centimeters cubed. Work out the height of the prism. Okay. So let's just go through and make sure all that information is actually on the diagram. The cross section of the prism is a right angled triangle. So the cross section is the kind of uniform face running all the way through the prism. It's that face there, isn't it? It kind of matches up with the one on the other side. And yeah, the right angle has been marked. Okay, so that's on there. The prism has a length of 25 centimeters. That's been marked there. And it has a base of the triangle is 5. That's on there. The volume of the volume of the prism is 750 cubic centimeters. That's not marked on there. Let's just kind of add it to our diagram. So this has got 750 cubic centimeters. I like to have everything there on the diagram so I can see it all together. Work out the height of the prism. Okay, so what we're going to have to do is we're going to have to use the volume of a prism formula because we've got most of the information here, and kind of work backwards to get the height. Okay, now the volume of any prism is cross-sectional area times its length. Okay, so the cross-section of this shape is a triangle, isn't it? And the triangle formula is half base height for area, isn't it? So area is half base times height. So you can use half base times height to find the area of that cross section, and then what you do is you take the area of the cross section and you multiply it by the distance between the front and the back face, which is 25 in this case, and that will give you the volume. Okay, so the volume of a cuboid is cross sectional area multiplied by length. Okay, and as I said, in this case the cross-sectional area is a triangle, so it's going to be half base height, and I'm going to multiply that by the length. Okay, So subbing in what I know, I actually know the volume. The volume is 750 centimeters cubed. So I'm going to write 750 at the front here. Okay. I know half. It's half. Now I know the base. The base is this line here. It's 5. So let's sub that into 5. Height, I don't know. Height is the one I'm trying to find. I'm just going to leave in h for now. And L, I do know. L is the length, isn't it? So the length is 25. Okay, so now I want to try and make h the subject. I want to get h, don't I? I want to solve for h. So I want to get h by itself. Now I've got that pesky half in there. I'm just going to get rid of that by multiplying both sides by 2 to start with. I normally see if I can cancel in one of the other numbers, but they're all odd. So that isn't going to work. So I'm just going to get rid of it by multiplying both sides by 2. So 2 lots of 750, that is 1,500. The half and the 2 will cancel on the other side, leaving me with 5 times h times 25. Now, 5 times 25 is 125, isn't it? So I'm just going to simplify that at the same time to 125h. Okay? So then to get h, I'm going to have to divide both sides by 125 then, aren't I? Okay, that will cancel with that there, leaving me with just h on the right. And then all I really need to know now is how many times 125 goes into 1,500. I can do that by counting up. 125, double it is 250, and then 250 doubled again would be 500, and 500 fits in 3 times. So I make that 12 times then, isn't it? Okay, so that makes the height equal to 12. 12 what? 12 centimeters, isn't it? So h equals 12 centimeters is my final answer. Question 7. The diagram shows a cube with edges of length x centimeters and a sphere of radius 3 centimeters. The surface area of the cube is equal to the surface area of the sphere. Show that x equals the root of k times pi, where k is an integer. Oh, what fun. Now this is a very interesting question, isn't it? Okay. Right, so we've been given the surface area of a sphere formula over here. Look, that's going to be very useful. The surface area of a sphere is 4 pi r squared. So I guess that's where we need to start, isn't it? Because we actually know the radius of the sphere we've been given, and that's the only thing I need to know in this formula to find the surface area. Okay, so let's start with the surface area. So surface area of sphere. Surface area is equal to 4 pi r squared, which is equal to 4 times pi times 3 squared. Well, 3 squared is 9, and 9 times 4 is 36. So that means that the surface area of this sphere is going to be 36 lots of pi. Okay, so that wasn't actually that hard. Okay, now over to the cube. It's a cube, isn't it? Yeah, it's a cube. That means all the sides are the same length, isn't it? So we've got x, x, and x. So what is the surface area of a cube? Surface area of a cube. Well, with a cube, you've got 6 faces, haven't you? I've got 6 faces, and each face has an area of its length times its length, which in this case is x times x. So each face has an area of x squared, and there are 6 of them, so that gives me a total of 6x squared. Okay, so I've got my surface area of my cube, which is 6x squared, and I've got my surface area of the sphere, which is 36 pi. Now we're told that these two things are equal to each other. Okay, so I can now equate those. So I can write underneath that 6x squared equals 36 pi. Okay, so I'm guessing then I want to try and get x by itself. Let's try dividing both sides by 6. That's going to leave me with x squared on the left, and 6 goes into 36 6 times. So that's going to leave me with 6 pi. Okay, Oh, then it's a lot easier than I thought. Then I'm just going to have to square root both sides then, aren't I? Square root both sides. Square root is the opposite of squaring. So if I square root x squared, I'm going to get x. And if I square root 6x, I'm going to get root 6 pi. Sorry, if I square root 6 pi. And that's it. Look, so it's in the right form. X equals the square root of some constant times pi. So my constant is 6, isn't it? So k is 6. Okay, all good. Not so hard. It looked horrible to start with, but actually it wasn't too bad. Question 8. Solve x squared equals 5x plus 24. Okay, so notice that this is a quadratic equation. It's not a linear one because I've got a little square in here, haven't I? I've got x squared. Okay, so when you want to solve a quadratic equation, you need to try and get everything to to one side first of all. So rewriting this with everything on the left, I'm going to get x squared minus 5x minus 24 is equal to 0, aren't I? Okay, because what I'm going to be doing is I'm going to be taking 5x away from both sides and taking 24 away from both sides. Another way of thinking about it is if you take something over the equal sign. So if something on one side of the equal sign pops over to the other side, we say change sides, change signs. So something on the right, which is positive, if it moves on to the left, becomes negative. Okay? Either way, we're going to get x squared minus 5x minus 24 is equal to 0. Now, hopefully, as this is the non-calculated paper, this is going to be factorizable. Otherwise, you've got to use the formula, which is hideous without a calculator. So let's hope it does. Now, in order to factorize it, the first thing I'm going to be looking at is this number on the end here, the minus 24. I'm going to just think about what the factor pairs of 24 are. We've got 1 and 24, 2 and 12, 3 and 8, 4 and 6. They're all the factor pairs of 24, aren't they? So one of those pairs is going to be the numbers that I pick to put in here. So I'm going to have an x and an x. It's a negative number on the end, so it's going to have to be 1 plus and 1 minus, and then it's going to have to be one of those pairs of factors. Okay, now because one is positive and one is negative, it's like I'm subtracting one factor pair from the one part of the pair from the other. If you have a quick look at the differences of these factor pairs, 24 and 1 have a difference of 23, 2 and 12 have a difference of 10, 3 and 8 have a difference of 5, and 4 and 6 have a difference of 2. So it's going to be that one there, isn't it? It's going to be the 3 and the 8. Okay, now the middle term is negative, it's negative 5. That means that the larger number needs to be the negative one and the smaller one is the positive one. So the 3 goes in that bracket and the 8 goes in that one. So when I get 3 take away 8, it's going to give me that negative 5 there. Okay? Right, so I've got two brackets multiplied together that gives me 0. That means one or other of the brackets must have been 0 to start with. That's the only way that can happen. So if this first bracket was 0, that must mean that x is equal to minus 3. And if this second bracket was 0, that must mean that x was equal to 8. So they are my two solutions. X equals minus 3, x equals 8. Question 9, we've got lots of different questions on the laws of indices here. Firstly, write down the value of 7 to the power of 0. Well, any number to the power of 0 is 1, isn't it? So don't have to think about that one. 7 to the 0 is 1. Part B, 3 times 3 to the 6 times 3 to the minus 6. I've got three numbers with the same base that I'm multiplying together. When you've got numbers with the same base multiplied together, you simply add the indices. So I've got a minus 6 there, a 6 there, and what's there? Okay, that's a kind of an invisible 1, isn't there? So I've got 1 plus 6 minus 6. That is going to give me 1. So the answer is 3 to the 1 or just 3. Okay? The other way of thinking about it is 3 to the 6 times 3 to the minus 6. They're going to cancel each other out, aren't they? Because negative index is the same as 1 over the positive one. So they would kind of cancel each other out, leaving you just with the 3 on the front. Either way, it's 3. Find the value of 2 to the negative 4. Okay? Now, 2 to the negative 4, I treat these different parts of the index separately. So that is a separate operation to that one. Okay, so a negative index means 1 over the positive version of that index. So I'm going to deal with the minus sign first. That means that is 1 over 2 to the power of 4. So I've got rid of the minus sign, but I've still got that 4 to deal with. 2 to the power of 4, which is 2 times 2 times 2 times 2, isn't it? 2, 4, 8, 16. So that is going to give me 1 over 16 as my final answer, 1/16. And then finally, I've got 27 to the power of 1/3. Now, a fractional index is the same thing as the cube root of that one. Whatever that number is here, look, whatever that denominator is here, that is the root that you take here. Okay, so if it was a half, then it would be the square root. If it was a 4, it would be the 4th root. Here it's a third, so it's the 3rd root. What's the 3rd root of 27? You should know your cubes. It's super handy with things like this. It's 3, isn't it? Okay, so a cube root of 27 is just 3. Question 10. The diagram shows a shape made from 6 identical squares. The total area of the shape is 5,406 square centimeters. Find an estimate of the length of one side of each square. Give your answer correct to the nearest whole number. So let's start out with the number I've been given. I've been given the number 5,406. Okay, I'm not going to do any maths yet. I'm just going to think about what operations I need to do. Okay, so that is the area of 1, 2, 3, 4, 5, 6 little squares. So if I want to find the area of one square, I'm going to have to divide that by 6, aren't I? So I'm going to have to take 5,406 and divide it by 6. Once I've done that, that will tell me the area of one of these squares. Now, if I want the length of one of these squares, I'm then going to have to square root that value then, aren't I? You know, so if that square had an area of 4, I'd have to square root it, and then I'd find that the length was 2 and 2. So once I've got that, I'm going to have to square root that. So the length of one of the squares is going to be 5,406 divided by 6, all square rooted. Okay, now that's a fairly hideous thing to be doing without a calculator. Okay, but it does say estimate, and estimate, when you're asked to estimate in maths, what we do is we round each number off to one significant figure, and then we do the maths there. Now, I was just thinking about this. If I rounded it off to one significant figure, but actually making my life harder for myself, because then I get 5,000 divided by 6, which is not so great, is it? 6 into 5,000. I think I'd rather leave it as 5,400, because that's actually easier to divide. So I'm just going to leave it like that instead. So 5,400 divided by 6. Now, the reason for that is 6 goes into 54, doesn't it? 54 is in the 6 times table. So then I can cancel easily that 6 into the 54. 6 goes into 54 9 times, doesn't it? Okay, so that's going to give me 900 square rooted. So what's 900 square rooted? I don't know. Well, I know. What do I know? Well, 3 times 3 is 9. So, but I want a 9 followed by 2 zeros. But what about if I do 30 times 30 then? 3 times 3 would be 9 plus 2 zeros. That would be 900, wouldn't it? So the square root of 900, that would be 30 then, wouldn't it? Okay. So I'm going to estimate that my length of one of my squares is 30 centimeters to the nearest whole number. Okay. Now, part B says, is your answer to part A an underestimate or an overestimate? You must give a reason for your answer. Okay. Well, what did I round? I rounded this one, didn't I? I rounded this one down. So 5,406 became 5,400. All the other numbers I didn't really touch. I just left them as they were. So that was the only one I really rounded, and I rounded it down. So the numbers I used were slightly smaller than the real numbers that, for the shape. So if it was slightly smaller and I divided it, it's going to stay slightly smaller. If I square root it, it's going to stay slightly smaller. So it's going to be an underestimation. So it's an underestimation as I rounded 5406 down. Okay, so I used a number smaller than the real value. Okay, I think that would do. Question 11. The diagram shows two rectangles A and B. All measurements are in centimeters. The area of the rectangle A is equal to the area of the rectangle B. Find an expression for y in terms of w. Okay, so we're told that the area of these shapes are equal then. So if we can write an expression for the area of each of these shapes, then we can then equate them, can't we? Okay, so let's start with the area of A. The area of A then is going to be length times width. So I've got 6 lots of 2w plus y. Now the brackets are important here because I'm multiplying 6 with all of 2w plus y and not just the first part of it. Same with the second one. So the area of B then is going to be 7w lots of 3y plus 6. Okay, so then we know that these two things are equal to each other. So I can say that area A equals area B, and then I can equate those two things together then. So 6 lots of 2w plus y is equal to 7w lots of 3y plus 6. Okay, so multiplying out the brackets, I'm going to get 12w plus 6y is equal to 21wy plus what's that, 7 times 6 is 42, 42w. Okay, right, so I've got terms in w, I've got terms in y, I've got terms in wy. Okay, now I want an expression for y in terms of w, so I need to have y equals. Okay, so everything that isn't to do with y I want on the right, and I'm just going to collect everything that is to do with y on the left. Okay, so basically I'm going to move this term over the equal sign, aren't I? Change signs, so when it pops over it's going to become minus, and I'm going to move this the other way around. I'm going to move that to the other side. So what I'm going to get is 6y minus 21wy is equal to 42w minus 12w. Okay, now on the right I can just collect like terms. That's super easy. 42w take away 12w, that leaves me with 30w. But on the left I've got 6y minus 21wy. Now I want to get y on its own. Now the only way I'm going to achieve that is if I factorize out that y out of the both terms. Okay, so if you've got like these mixed terms, you're going to have to factorize the thing you want out of it. Okay, so actually there are two common factors here, aren't there? Because 6 and 21 have a factor of 3. So I'm going to factorize out 3y out of these two terms. So 3y taken out of 6y is going to leave me with 2, and 3y taken out of 21wy is going to leave me with 7w. Okay, so I've got 3y lots of 2 minus 7w equals 30w. Then the last step then, just going to shifty this up a little bit, give myself a bit more space. So then I'm going to divide both sides by 3 lots of, let's divide the 3 first, because that's quite easy. Let's divide both sides by 3. So divide by 3, that will cancel, and divide by 3, that will cancel. Leaving me with 10w. So I'm going to get y lots of 2 minus 7w equals 10w, and then I'm going to divide both sides by that bracket. Okay, I'm not going to bother writing it down again underneath and cancel it out because I don't want to. So that is y equals 10w divided by 2 minus 7w. Okay, and that's my final answer. So I've got an expression 4y in terms of w. And now the trick to it really was that factorisation. That's the bit that that people struggle or don't see in the exam. Okay, so if you're revising for your exam, this is a super handy trick. Okay, looking to factorise your y out of your thing. That really is the best and easiest way to get y by itself. Question 12. The cumulative frequency table gives information about the heights in centimetres of 40 plants. Okay, and then I've got a cumulative frequency table here. Now notice it is cumulative frequency and not frequency. So normally you're given a frequency table and asked to draw a cumulative frequency curve, but you've already been given a cumulative frequency here, so don't go be adding these up, okay, because you're going to go all terribly wrong. Okay, so then when you're plotting a value against cumulative frequency, you use the upper class boundary to plot it, don't you? So I'm going to be plotting 5 against 4, 10 against 11, 15 against 24, 20 against 34, 25 against 38, and 30 against 40. I can plot an extra point as well. I can plot a point at 0, 0, 0 in this case. I can plot a point at the left-hand bound of the bottom one there at 0. So I am going to plot that point in as well. So the first point I'm going to plot is 0, 0. Okay, and then I'm going to go to 5 and plot one at a height of 4. Okay, then the next one is at 10 at a height of 11. Okay, and then I'm at 15 at a height of 24. I've got 10 little squares in a space of 10, so each little square is just worth 1 in this case, so it's a nice super easy scale to use. 20 goes to 34, and 25 goes to 38, and then I've got 30 at 40. Okay, so it's got that very distinctive S-shaped cumulative frequency curve, which I'm just going to join up with a nice smooth line. Now it doesn't matter if your line is a bit wibbly wobbly, but what does matter is if you miss the points, or if you do what's called feathering, where you kind of have a couple of goes at a line and end up having like more than one line. Okay, so you just want a single line passing through each of your points. Don't worry if it wobbles a little bit. That's not the worst thing that could happen. Okay, so then I've drawn my cumulative frequency curve. I didn't have to work out cumulative frequency, it was already given, so just be aware of that. Use your graph to find an estimate for the median height of the plants. Okay, so how many plants have I got? I have got 40 plants. Okay, so the median is the middle, so half of that is going to be at 20. Now, strictly speaking, when you're finding the median, you're meant to add 1 before you divide by 2, aren't you? But when the number of items is large like this, in this case 40, adding 1 doesn't really do very much. So we're just going to read across halfway. So 40 divided by 2, I'm just going to write it down. 40 divided by 2 equals 20. So and then I'm going to look across from 20 until I get to my curve. I'm going to switch directions, and I am then heading on down. So then that value there should be my median. What is that value? So I've got 10 divisions this time between worth 5. So each one of those divisions is worth 0.5, or 2 little squares is 1. So I reckon that is it 14 or 13 and a half? I'm going to go with, it's kind of halfway between 14 and 13 and a half. I'm going to go for 13.5. Median equals 13.5 centimeters. I think I could probably get away with 14 there as well. My arrow is kind of pretty much halfway between those two squares. You usually get about like half a square tolerance. So I think 13.5 or 14 centimeters would probably be acceptable for my diagram. Question 13. Ted is trying to change 0.43, and it's a recurring decimal, isn't it? Got 2 dots, 43, so it's 0.4343434343. Here's the start of his method, or he's trying to convert it into a fraction, sorry. So here's the start of his method. let x be the recurring decimal, and then he's multiplied it by 10 to get 10x is equal to 4.34, and then he's subtracting the one thing from the other in the hopes that it will cancel out. But it's not going to, is it? Because if you have a look at the bit after the decimal point here, this is 3, 4, and this is 4, 3. So when you take one away from the other, it's not going to cancel each other out like it's meant to. Okay, so he would have been much better off doing what, do you think? I think he would have been much better off, rather than times him by 10 at this point, he really should have times by 100. So at this point here, he should have got 100x is equal to 43.43, and then that would be reoccurring like that. And then if he took 100x and then took the x away, he would be subtracting 43.43 minus 0.43, and then that bit there then would cancel with that, and he would be left with 99x equals 43, and then dividing both sides by 99 would have given him x equals 43 over 99. Okay, so what did he do wrong? He multiplied by 10 and not 100. Okay, so Ted multiplied by 10 and not 100 as he should have. And the reason it isn't going to work is because subtracting 4343 from 343434 is not going to cancel. So I'm going to say he will not be able to cancel the recurring decimal this way. I think actually what I did there when I actually showed the right answer was probably a better explanation than what I've written down in words. Actually, you can just do maths as part of your explanation. It's perfectly acceptable. It's a maths paper. Question 14. Here is a shape with all its measurements in centimetres. The area of the shape is a square centimetres. Show that a equals 2x squared plus 24x plus 46. Okay, so we've got a compound shape made up of two rectangles here. Now, which is the best way to break it up? I think probably the easiest way is to do it this way. If I break it into two rectangles, then I can work out the area of the rectangles separately and add them up, can't I? Now, if I do that, then I'm going to have to change this one here, isn't it? Because if that's 4, then the bit from here to here then is going to be 4 less than x plus 11. So that is going to be x plus 7 then, isn't it? Okay, so the top rectangle has got an area of, let's call this A1 and A2. So then A1 is going to be 4 times x plus 1, 4 lots of x plus 1. Removing the brackets, that's 4x plus 4, isn't it? And then A2 is going to be, well, I deducted 4 from x plus 11, so that is x plus 7 multiplied by 2x plus 6, the length and width of A2. So I've got double brackets here, so for first outside inside last, or smiley face, to multiply all that out. We're going to get x times 2x, that's 2x squared, x times 6, that's 6x, 7 times 2x, that's 14x, and 7 times 6 is 42. Okay, so notice I've got two terms in x here, so let's collect those together. So I've got 2x squared plus 20x plus 42. So then the total area is going to be A1 plus A2, which is my 4x plus 4 plus my 2x squared plus 20x. Am I going off the edge here? Plus 42. Let me just shimmy that over a little bit because I think I've fallen off the edge. There we go, that's a bit better. So, except half of my thing didn't move with it. Let's just write that bit out again. So A1 plus A2 equals 4x plus 4 plus 2x squared plus 20x plus 42. Collecting like terms, I've got one term in x squared, 20x squared. I've got two terms in x. I've got 4x and I've got 20x, which makes 24x. And I've got two constants. I've got 4 and 42 there, making 46. Okay, are we good? Yep. 46 matches, 24 matches, 2x matches. So we're all good, aren't we? So we showed it. Question 14. Show that 4x plus 3 over 2x plus 3 over 5 can be written in the form ax plus b over cx, where a, b, and c are integers. All right, so basically we've got two fractions that we're adding together, and we want to make it into one fraction and see what it looks like. Okay, so here's my first fraction here. Here's my second fraction here. Adding them together, make one fraction. Then hopefully it will look like this one over here then, once I've added it together. Now, just because it's algebra doesn't mean the rules change. When we're adding fractions together, the first thing you need to do is find a common denominator, isn't it? Now, if I had a fraction over 2 and a fraction over 5, then the common denominator would be 10, wouldn't it? I've got 2x and 5, so the common denominator here is going to be 10x. Okay. Now, how many times does 2x go into 10x? It goes 5 times. So I'm going to be I've times that by 5, so I'm going to have to times that bit by 5 as well. So on my numerator, I'm going to get 5 lots of 4x plus 3, aren't I? Okay. And then plus... then 5, how many times does 5 go into 10x? I would have multiplied that by 2x to get 10x. So I have to do the same thing with that. I have to multiply that by 2x. So 3 lots of 2x, that's 6x, isn't it? Okay, so that's what I get. Let's just remove that bracket on the top. So multiplying out the bracket, multiply everything in the bracket by 5. So 5 times 4x, that's 20x. 5 times 3 is 15. Plus I got the 6x all over 10x. Okay, like terms, yes, I've got 20x and 6x, which I can add together. That is going to give me 26x plus 15 all over 10x. Now, is that of the form that I was asked to find? Now, remember, I wanted it in the form ax plus b over cx. ax plus b over cx over 10x. So that works, isn't it? It's of the right form. It's all looking good. I've got numbers where a, b, and c is, but all the x's are the same. Yeah, it's good. 26x plus 15 over 10x. Question 16. There are only 3 red counters and 5 yellow counters in a bag. Jude takes at random 3 counters from the bag. Work out the probability that he takes exactly 1 red counter. Now I could do this as a huge like probability tree. But it would have so many branches. Which would be a lot of work. I don't really want to do it that way. I'm gonna have to do it do it slightly more ad hoc, I think. Otherwise I'm gonna be here forever. So the probability of exactly 1 red. Okay, so that is the probability of pulling a red one out the first time, followed by a yellow, followed by a yellow. Or it could be the probability of getting a yellow, then a red, and then a yellow. Or is add in probabilities, isn't it? Or is add and is times. So or yellow, yellow, red. That's a possibility as well, isn't it? Okay, so probability of exactly 1 red is either he pulls a red on the first try and then a yellow and a yellow, or then he pulls a yellow and then a red and a yellow, or a yellow, yellow, and then a red. They're all the options. That's the only way you can do it. Okay, so what is the probability then of him pulling a red one first go round? Okay, well, if you think about it, on the first selection, there are 8 counters in total, 3 of which are red. So the probability that he pulls a red one out first go is going to be those 3 red counters over a total of 8 counters, isn't it? Okay, so I think maybe I'll draw these. I've got red and yellow, haven't I? So let's say like red, yellow, yellow. Okay, so then on the first selection, if I pick a red one out, so I've got that one there, then for my second selection, I want to know the probability of picking a yellow one out. So yellow, well, there are 5 yellow ones still because I picked a red one first time. And there are now a total of how many are left? There are these ones left to pick from, which are 7. There are 7 token counters left to pick from. So the probability of picking a yellow one on my second selection is going to be 5/7. Okay, so let's say I picked that one there on my second selection. What have I got left for my third selection? So now on my third selection, I've got what's the probability of pulling out a yellow? Well, now I've got 1, 2, 3, 4 yellow ones remaining, and I've got 6 counters remaining altogether. So it's 3/8 times 5/7 times 4/6. Okay, so that's the probability of red, yellow, yellow. Okay, now I said or is add and is times because, you know, for red and yellow, I need to multiply those together, don't I? Right, now next one, probability of yellow, red, yellow. So probability of yellow, red, yellow. Yellow on the first selection, 5 yellows there on that first selection out of a total of 8. Second selection, pull in a red. There's going to be 3 of them there because I haven't taken any red ones out. There are now 7 to pick from. And then for the third selection, there are now 4 remaining yellows because I picked one out on the first go. And there are 6 counters altogether left. Okay, and then so that's 5/8 times 3/7 times 4/6 for that second yellow, red, yellow probability. And then finally, probability of yellow, yellow, red. Probability of yellow on the first draw, I already said, was 5/8. Probability of yellow on second draw is going to be 4/7. 1 less yellow, 1 less counter. And then finally, probability of red on the last draw. There are 3 reds still because I haven't pulled one out yet. There are 6 left, so that's 3/6. Okay, so that's that. Whew. Right, so that's quite a big sum to do without a calculator, but let's be smart about it. 3 times 5 times 4. Can you see that on the top of these, 3, 5, 4, 3, 5, 4, 3, 5, 4. So each group of these is made up of a 3 and a 5 of a 4 on the top, 3, 5, 4, 3, 5, 4. And on the bottom, we've got 8, 7, 6, 8, 7, 6, 8, 7, 6. They're all the same on the top and on the bottom. So actually, we've got 3 identical fractions here. So if we work out one of them, we worked out all of them. So it's not quite as big a job as it first looks. So what is 3 times 5 times 4? 3 times 4 is 12, times 5 is 60. So the numerator of that first fraction is 60. 8 times 7 times 6, that's a little bit more hard work, isn't it? I'm going to have to do a little bit of long multiplication for this one. Do I? Yes, I do. Going to have to do it. So 8 times 7 is 56, and then I want to times that by 6, don't I? So what's that? 6 6 is a 36, 6 carry 3, 5 6 is a 30, plus 3 is 33, and then that's it, 336. So that's 336 on the bottom. Okay, so I've got 60 over 336 plus 60 over 336 plus 60 over 336. In other words, I've got 3 of these. Okay, so 60 times 3, that is 180 over 336. Okay, a lot of work without a calculator, but we got there. 180 over 336. We did it. Question 17. On the grid, show by shading the region that satisfies all of these inequalities. 2y plus 4 is less than x, x is less than 3, y is less than 6 minus 3x, and then label that region R. Okay, so with each one of these, I want to plot the equation first, and then we'll try and work out what side of the equation we're talking about. So let's take that first inequality. 2y plus 4 is less than x. Now, first off, I'm going to find the equation of that line. So I'm going to replace the less than sign with an equal sign to start with because I just want to draw it. And then I want to get into the form y equals mx plus c. So if I've got 2y plus 4 equals x, let's take 4 away from both sides. I'm going to get 2y equals x minus 4, and then dividing both sides by 2, I'm going to get y equals a half x minus 2. Okay, I'm just dividing the 2 into the x and into the 4 to get half x minus 2. Okay, so this tells me the line has a gradient of a half and a y-intercept of -2. Okay, now you can also draw this as a table of values, so you know, kind of pull out some values for x, sub it in here and find the value of y. But you can also plot a graph using its gradient and intercept. So for instance, I know that the y-intercept of this line is at -2, so I know my first point is going to be down here at -2. Then for every one square I go along, I'm going to go half up because the gradient is a half. So if I go 2 along, I'm going to go 1 up, so the next point is there. If I go 2 along, I'm going to go 1 up. If I go 2 along, I'm going to go 1 up. And back the other way as well. Okay, so I can quickly plot all those points. Now, if you don't like doing it that way, you can just do a table of values, x, y, find some values, and then plot them. Okay, but I find it quite easy just to use the intercept and the gradient for drawing straight lines, especially when you've got a lot to do like this. Right, so that's that one. Now, this one is strictly less than, so I'm going to have to draw a broken line on this one because the line itself is not part of the region. Okay, so if it's strictly less than or strictly greater than, you use a dotty line, a broken line. If it's less than or equal to, you can use a solid line. Okay, so I'm going to have a broken line going through that. So that is the line y equals a half x minus 4. Okay. Right, so then that's the first one. Now the next line, x, I need to use x is less than 3. Now the line x is equal to 3 is a vertical line passing through x is equal to 3. Now again, it's strictly less than. So again, I'm going to be using a broken line down here. Okay, so this is the line, x is equal to 3, isn't it? I like to label my lines. And then finally, I've got y is less than 6 minus 3x. So y is less than 6 minus 3x. Okay, so if I was going to draw that as a line, that'd be y equals minus 3x plus 6. So the gradient is minus 3, and the intercept is 6. Okay, so I can plot a point up here at 0, 6. The y-intercept is 6, and the gradient of 3 means for every one square we're going along, we're going to go 3 down in this case. So 1 along, 3 down, 1 along, 3 down, 1 along, 3 down. Okay, so it's a very quick and easy way of drawing the line using the gradient and the intercept like that, I find. Now again, this is strictly less than, so again, it's a broken line that you need to use for this one. Okay. Right, so now what we need to do is we need to work out which range they're talking about. Okay, so what I tend to do is I like to pick a point and then see if it's true or not, or see if each of the inequalities hold. Okay, so let's pick some various points in the various regions. Like there are various regions that these lines have broken my shape up into. So for instance, there's this big region over here, there's this one up here, there's this one over here, there is this region down here, there's a kind of teeny tiny one in there, there's one down here, look, and then there's another one over here. So this diagram has been divided up in all of those different regions, and we need to work out which region is R, which one satisfies all those inequalities. Okay, so let's test this region here first. This is a point here, look, 0, 0, that lies in the region. So what you do to test a region is you pick a point and you see how that works out with the equation. So I've got my So if I've got 0, 0, does 0, 0 work with these equations? So if x is 0 and y is 0, is 2 lots of y plus 4 less than 0? No, because 0 plus 4 is 4. 4 is not less than 0. So that one would not be true at 0, 0. This one would be true, but it doesn't matter because they all need to be true. And finally, 0, is that less than 6 minus 0? Yes, it is. So some of them hold and some don't. So we can use that to try and help improve our guess. So it was true for x is equal to 3. So if you have a look at x equals 3, it is this line here. Okay, so we do want that side of x equal to 3. So we're on the right side of x equals 3. We're also on the right side of y less than 6 minus 3x, which was, if you remember, was this one. So we're on the right side of this one, but we're on the wrong side of the first line, this one here. Okay, so I'm going to make a second guess now. I'm going to guess then this time using a point in this region. I think it's going to be in this. I think it's going to be in this region down here. So I've picked that point down there. Okay, so I've picked the point 0 minus 4 then. 0 minus 4. And I'm going to just check again whether or not that point satisfies all the inequalities. Okay, so if x is 0 and y is negative 4, does that work with 2y plus 4 is less than x? Is 2 lots of negative 4 plus 4 less than 0? Well, 2 lots of negative 4 is negative 8. Plus 4 is negative 4. Negative 4 is less than 0. So in this case, this one is true. Is x less than 3? Yeah, 0 is less than 3, so that one is true. Is y less than 6 minus 3x? Well, is minus 4 less than 6 minus 0? Yes, it's true. So that works for all of them. So I think we found our region. Okay, so our region is this yellow bit down here. So I'm going to just label that region R, as they told me to, and then I'm done, aren't I? So that's the region R. Question 18. Here is a trapezium ABCD. The area of the trapezium is 66 square centimeters, and we're told that the length of AB to the length of CD is in the ratio of 2 to 3. Find the length of AB. Okay. So what have we got everything on in the question in this diagram? I just like to write everything in. So the area of the trapezium is 66 centimeters squared. So I'm just going to write that in the middle. This is 66 centimeters squared. So I've got it there so I can look at it. The length of AB to the length of CD is in the ratio of 2 to 3. Well, where's AB? AB is up here, look. So that's AB. So the length of AB to the length of CD is in the ratio of 2 to 3. Where's CD? It's down here. Okay, so these are in a ratio of 2 to 3. So for every 2 you've got up here, you've got 3 down here. Okay? But we don't know how long it is. I'm just going to write 2x and 3x there just to remind me that it isn't 2 and 3. It's they're in the ratio of 2 to 3. Okay? Ooh, so we need to find the length of AB. This is not so straightforward, is it? Okay, but luckily we've got an angle down here. What's that telling us? That angle needs to tell us something. Now, to find the area of a trapezium, do you know the formula? Area of a trapezium is half times A plus B times H. Okay? Now, A and B are our two parallel sides. So in this case, it's going to be that one and that one. Okay? And why did I write plus H? It's times H. Half ABH. Okay, now H is the height of the trapezium that I don't have. I'm just going to draw it in. And I'm going to draw it in here. Okay, I wonder if you can guess why. I'm going to draw the height in there. Okay, so that is the height of the trapezium that I'm looking for. Okay. So if I knew the height, I could probably then use the A and B, the ratio of A and B to them, and the area to work out what the lengths are. I think I can do this. Okay, so I need to work out H next. I'm pretty sure that's the next step. Okay, but I've got this angle here. Okay, 30. and I know this side here, which in a right angle triangle has a special name. It's the longest side, so we call it the hypotenuse. So that's H, isn't it? Okay, well, that is the, let me use capital H so I'm not messing it up with the other H. So that's the hypotenuse, and then the side opposite the angle is the opposite. Okay, so that's the opposite side. This one would be the adjacent side, wouldn't it? But I don't know what it is, and I don't need to find it. So I'm not so bothered about the A. So I've got the hypotenuse, and I want the opposite. This seems to be a job for trigonometry, and in particular, trigonometry in right angle triangles. So I'm going to pull up my mnemonic SOHCAHTOA to try and help me remember which ratio that I'm going to need in order to work out that H. Okay, so I've got the hypotenuse and I want the opposite. So which ratio has got to do with the hypotenuse and the opposite? It is this one here, isn't it? So I know that sine theta equals op over hype, where theta is 30 degrees in this case. The opposite is what I'm looking for, it's H, and the hypotenuse I know, which is 6. Okay, so that tells me that H, the height of the trapezium, is going to be 6 lots of sine 30. Now, I don't have a calculator, but luckily 30 is one of the values that I have memorized. There are certain values that you need to know for the non-calculated paper. You need to know the sines, cosines and tangents for 0, 30, 45, 60 and 90. So this one is on my list, and I know that the sine of 30 is a half. Okay, so I know that H equals 6 times a half. Now there's no way around it. You're going to have to memorize this table one hand. There are tricks to it. I'm sure your teacher's told you a few, but otherwise, yeah, you need to remember it somehow. So H is equal to 3. So I know the height of my thing now, and I know the ratio of them, and I know the area. So I reckon I've got enough now to work it out. Okay, so I've got area equals half A plus B lots of H. Now I'm going to use 2x and 3x because I don't know the actual length of those lines. So I'm going to sub all that in. So area equals half A plus B H. Area then I know is 66. That was given in the question. Half is just a half. A, I'm going to use 2x because I don't know how long it is. And then B, I'm going to use 3x. And then H, I've just found out, is 3. Okay? Right. So what can I do with that then? Again, I've got no even numbers to cancel my 6 with. So just like before, I'm just going to times both sides by 2 to get rid of that. Half there. And then so that's going to give me 132 is equal to, and then I've got 2x plus 3x, which is 5x inside the bracket, times 3. Okay, so 132 is equal to 5 times 3 is 15, 15x. So then x is going to be 132 divided by 15. Well, it's not the nicest division, is it? So what's that then? 15's into 132. So 15 goes into 150 10 times. So it goes into 135 9 times. So it goes into 120 8 times, isn't it? So that's going to be, x is going to be 8 and 12 left over. So 8 and 12 15ths, which is 8 and cancelling that down. 4/5, 8 and 4/5, which is 8.8. 8.8 what? 8.8 centimeters. X is 8.8 centimeters. Now we're not quite done here because we found X, but X was something that I actually invented. It wasn't in the original question. What I wanted was the length AB. Okay, so I said that AB was going to be 2x. So AB is going to be twice my answer then, isn't it? So AB equals 2 lots of x, which is equal to 8.8 times 2. 8.8 times 2, that is 17.6 centimeters then, isn't it? Okay. So that was a fun question. Question 19. Show that a plus root 12 over 5 plus root 3 can be written in the form a plus root 3 all over b, where a and b are integers. Well, when I look at this, I can see that I have got an irrational denominator here, and then the form that they want me to put it in has got a rational denominator, no roots in it at all. So the first step here is going to be to rationalize that denominator, I think, and then see what drops out. That's what I'm gonna do. I'm gonna take 8 plus root 12 over 5 plus root 3, and I'm gonna try to rationalize the denominator. Now, when you've got a two-part denominator like this, like a number plus a surd, then how you rationalize it is you take the same things, 5 and root 3, but you switch the sign in the middle. So if it's 5 plus root 3, you're going to use 5 minus root 3. If it's 5 minus root 3, you're going to use 5 plus root 3. Okay, now I'm just going to use that over itself, and now anything divided by itself is 1. So multiplying through by this fraction isn't going to change the overall value of my my answer, but what it will do, it will kind of shake up what it looks like and kind of reformulate it a bit. So if I'm multiplying these two things together, 5 plus root 3, 5 minus root 3 on the bottom, and on the top I'm going to get 8 plus root 12 times 5 minus root 3. Okay, so I've got a lot of work to do here. So I've got to multiply out brackets top and bottom. So 8 times 5, 8 times, yeah, I've got to do FOIL basically on this, haven't I? Or 2 eyebrows, a nose and a mouth. Okay, let's do the top first. 8 times 5, that is 40. 8 times negative root 3, that's minus 8 root 3. Root 12 times 5, that is plus 5 root 12. And root 12 times root 3, I'm just going to write it like it is. I'll deal with it in a minute. So root 12 root 3 like that on the top. Okay, now on the bottom things go a little bit easier because I mean I could do it all long, but actually you don't need to. Let me show you doing it long, and then I'll show you how I'd actually do it then. So if I was going to do the same thing on the bottom, I would get 5 times 5, which is 25. I'd get 5 times minus root 3, which would be minus 5 root 3. I'd get root 3 times 5, which would be plus 5 root 3. And I'd get root 3 times minus root 3, which would be minus root 3 root 3. Okay? But you should notice then that they cancel, and root 3 times root 3 is just 3. So actually you can do this a whole lot quicker. Once you know the form of it, I wouldn't do it like that. I would just do 5 times 5 is 25 minus root 3 times root 3 is 3. So I just do it like that, much quicker. Okay, so once you know what you're doing with these rationalized denominators, it makes it a whole lot quicker. Right, so then 25 take away 3 is 22 on the bottom. And then on the top, what have I got here then? Let's see if I can simplify this down a bit then. So 40 minus 8 root 3 plus 5 root 12. Now root 12, 5 root 12, let me just do it over here. Root 12 is the same thing as root of 4 times 3, isn't it? But I can root 4, so I can say that's the same thing as 5 root 4 root 3, and root 4 is 2, so that's the same thing as 10 root 3. So I can rewrite 5 root 12 as 10 root 3. Okay, so then that means I've got 40 minus, I can't really do much with the 8 root 3 just yet, but the 5 root 12 I can rewrite as 10 root 3. And root 12 root 3, that's the same thing as the root of 12 times 3, which is root of 36, which is root of 36 is just 6, isn't it? So that becomes minus 6 on the top. Okay, so then I've got numbers. I've got 40 take away 6, that is 34, and then I've got like terms here as well, and I've got minus 8 root 3 and plus 10 root 3. You can collect these together just like you can with algebraic terms. 10 root 3 take away 8 root 3 is 2 root 3. So plus 2 root 3 all over 22. Okay. Now, can I cancel that down any further? I've got like all of these numbers are divisible by 2, aren't they? So I'm going to then just divide every term by 2. Another way of thinking about it is kind of, if you want to do it long, so you could factorize 2 out of everything and say that's 17 plus root 3 over 2 lots of 11, and then cancel those down. But essentially what you're going to get is dividing everything by 2 and getting 17 plus root 3 over 11. Okay, so again, when you get a bit better at algebra, that you can kind of do these kind of shortcutty things. Right, 18 plus root 3 over 11. Now, is that in the form a plus root 3 over b? Yes, it is. A is 18 plus root 3 over b, which is 11. That fits the form, doesn't it? Good job. Question 20. The diagram shows the graph of x squared plus y squared equals 30.25. Yes, it does, because anything in the form x squared plus y squared equals r squared is the equation of a circle with radius the root of that number, isn't it? So I expect root 30.25 is 5.5 then in that case. Yes, so that's what we've got. Now we need to use this graph to find estimates of the solution of the simultaneous equation x squared plus y squared equals 30.25 and y minus 2x equals 1. Okay, right, well we've already got that first one drawn, haven't we? That's the one that we've got drawn on the graph. So basically, if we plot that one on the graph and look at its intercepts, then we should have solved it. Okay, so what does that graph look like? Let's just rearrange it so it's in the form y equals mx plus c by adding 2x to both sides. I'm going to get y equals 2x plus 1. Okay, so that means that the gradient is 2 and the y-intercept is 1 then, isn't it? So m equals 2, c equals 1. Now again, I did say earlier, you can just find values of x and y. So pick some various values of x along your axes, sub them into the equation and find values of y. Personally, I'm quite happy drawing the equation. I can draw a plot, or I can plot a line from its gradient and its intercept. So I'm going to plot the point, the y-intercept first. So I'm going to have a point at 0, 1. And then I'm going to use the gradient then to find my other point. So for every 1 unit go along, I'm going to go 2 units up, 1 along, 2 up, 1 along, 2 up. In the other direction, 1 to the left, 2 down, 1 to the left, 2 down, 1 to the left, 2 down, 1 to the left, 2 down. Okay, so I find that a whole lot quicker than drawing a table of values and plotting them. If you like that method, you can use it too. If you don't, just put the values in, you know, just pick some values. You could pick out -4, 0, 4 and so on and plot those, work them all out and plot them if you want to do it long, or just try this way, it's quick. So I'm just going to join those points that I found with a straight line. Annoyingly, my ruler's kind of jump. It should be something like somewhere between the two jumps that my ruler's happy to do. So that's about as best I'm going to get on this thing. Okay, so then to find or to solve this simultaneously, the solution of simultaneous equations are where their lines intersect on the graph. So one solution is up here, look, where the lines cross, and the other one is down here. Okay, so I've got one solution up here. What is that point there? Okay, it's slightly to the right of 2 in the direction of x, but not massively. I'm going to say it's like about 2.1 in the direction of x. In the direction of y, it's slightly above 5. I'm going to say it's 5.1. So it's going to be 2.1, 5.1. It's going to be one of my solutions. Okay, now the other one down the other end is kind of like, is it the mirror image? No, it's not quite, is it? So that's going to be -2. I make that about -2.8 in the direction of x. -2.8. And then in the direction of y, that is about -4.8. Okay, so there are my two coordinates. Now I'm not sure if this question wants it written as coordinates or x and y values. So let's just write it down as x and y values as well, just to be sure. So x equals 2.1 when y is 5.1, and x equals minus 2.8 when y is minus 4.8. Okay, so I've written it as coordinates, I've written it as x and y values. I think I've got all my bases covered. Let me just tie that up a little bit because the 8 went a bit weird. Minus 2.8. Okay, I'm happy with that. Let's move on. Question 21. The functions f and g are such that f of x is equal to 3x squared plus 1 for all x greater than 0, and g of x equals 4 over x squared for x greater than 0. Work out g of f of 1. Okay, so part A says work out of g of f of 1. Now, g of f of 1, this is what we call a composite function. So you take one function, you sub it inside another one, and you kind of work from your inside going outwards. So starting closest to the number and working your way out, you can see you get to f first, and then you get to g. So that means that f is inside g. So you start with f of x, and then you put whatever your answer is, and you put it inside g of x. Okay? So g of f of 1 is that you're going to start with f of 1 and work that out. So what's f of 1? F of 1 is equal to 3x squared plus 1. So that's going to be 3 lots of 1 squared plus 1. Well, 1 squared is 1, times 3 is 3, plus 1 is 4. Okay, so f of 1 is 4. So then what you're going to do is you're going to take the answer for that and you're going to feed it inside g. So basically we need to work out what g of 4 is then. So we're going to take the output of f and we're going to put it into g. So g of 4 then is going to be 4 over x squared, which is 4 over 4 squared. Okay, which is 4 over 16, which is a quarter. Okay, so then g of f of 1 is going to be 1/4. Right, for part B, we're told that the function h is such that h equals f of g to the minus 1. And then we want to find h of x. Okay, so again, working backwards, look, this means take the function g and sub it inside of f. Okay, so h is going to be this function here, the 4 over x squared, written where the x appears there in f of x. Okay, so in other words, I'm just going to write fg of x to start with. Fg of x is going to be f of x, 3, well, where the x squared would be, plus 1. I'm going to replace that x with what g of x is. So it's going to be 3 lots of 4 over x squared all squared. Okay, so rather than 3x squared plus 1, which f is normally, it's 3 lots of that g of x function all squared plus 1. Okay, hopefully that makes sense. And then so removing the brackets, I kind of have to square both bits, don't I, when you've got a bracket squared like that. So I need to square 4 and square x squared. So I'm going to get 4 squared is 16, and then 16 times 3, 16, 32, 48. 48 over, and then x squared all squared, that's x to the 4. So I'm going to get 48 over x to the 4 plus 1. So that's what f of g of x is. Now, when I want to find h of x, I need to find the inverse of that function. So h of x is going to be the inverse of what I've just found. Okay. Now, to find an inverse, what I normally do is I say let y be my function that I want to find the inverse of, and then I rearrange it for x, and then I rewrite the y's back for x's again. Okay, so we start off with y equals 48 over x to the power 4 plus 1. I'm going to make x the subject. So the first thing I'm going to do is going to subtract 1 from both sides. That's going to give me y minus 1 is equal to 48 over x to the power 4. The next thing I'm going to do is I'm going to times both sides by x to the 4 and divide both sides by y minus 1, which will have the effect of switching these two around. Also, if you just know about cross multiplying, then you might probably already be quite comfortable with just switching those around like I am. So that's x to the 4 is equal to 48 over y minus 1. Just swapping those around using cross multiplication. And then to get x by itself, then I'm going to have to take the fourth root then of that. So x is going to be the fourth root of 48 over y minus 1. Okay. Now, in order then to find the inverse function h of x, I'm going to take the format of that answer, but I'm going to replace x with h of x, and I'm going to replace y with x. So h of x is going to be the fourth root of 48 divided by, I'm just going to write x instead of y, x minus 1. Okay, that's kind of how I do it. And I think that's the answer. The fourth root of 48 over x minus 1. Well, not a very nice answer. Question 2. Find the coordinates of the turning point on the curve with equation y equals 9 plus 18x minus 3x squared. You must show all your work in. Now I'm looking at this and wincing inside for two reasons. Firstly, because I've got a number in front of the x squared term which complicates things somewhat. And then finally I've got a minus sign in front of the 3x squared term which complicates things even more. So this is a really hideous turning point question. Okay, so buckle up, we've got to get it done. Right, so finding the turning point for most GCSE students would involve completing the square. Now if you're doing further maths, you could actually attack this question using differentiation. I'm not going to go into that in this question because this video is aimed at GCSE students, but if you're doing further maths GCSE, there's an additional technique that you might be able to apply here that might simplify this a whole lot for you. So give it a go doing it that way. Okay, but assuming you're not doing further maths, we're going to do it by completing the square. Okay, which is a bit long in this case because of the minus and the 3. Right, so what I'm going to do is I'm going to rewrite this with the x at the front. Okay, the x squared at the front. So I'm going to rewrite it as minus 3x squared plus 18x plus 9. Okay, and then what I'm going to do is I'm going to factorize out that negative 3 out of the first two terms. Okay, which is, what is it? So if I take negative 3 out of x squared, I'm going to get left with x squared. If I take negative 3 out of positive 18x, it doesn't really have a minus sign in it, so I'm kind of cheating a bit, but it's going to be minus 6x in that case, because negative 3 times negative 6x is positive 18x. And it's a bit cheaty, but it kind of does the job, and it's going to help us out a whole deal. Right, so then what am I going to do? And then I'm going to complete the square on x squared minus 6x then, isn't it? So I'm going to put a chunky bracket in there because I've got two brackets to do and I want to distinguish between the two. So I'm going to replace x squared minus 6x with x minus half of 6, which is 3, all squared. Now I've introduced, by doing that, by replacing x squared minus 6x with x minus 3 all squared, I've actually introduced 3 squared more than there was to start with, so I need to take that away again, plus my 9 on the end. Okay? Now what? Now this term here needs to come out of this big square bracket, but when it pops out, it's going to have to multiply with this minus 3 at the front. Okay, so just bear that in mind. So I've got 3 squared, which is 9, so it's subtract 9. So I'm taking that minus 9 out of that bracket, but as I do, I'm going to have to multiply it with the negative 3 at the front. So it becomes minus 3 lots of x minus 3 all squared minus 9 times negative 3, which is positive 27 plus 9. Okay, does that make sense? I hope so. So like I say, as I'm taking this bit here out of the brackets, 3 squared is 9, but as it pops out, I have to multiply it by that thing in the front of the bracket, which changes it from negative 9 to positive 27. Okay, so that's all good. Right, so then just tidying it up a little bit now then. So that's minus 3 lots of x minus 3 all squared plus 27 plus 9. That's plus 36, isn't it? Okay. Right, so then we've completed the square. Then what we need to know now is the turning point. Now the turning point happens when the bracket is 0. Okay. And so what value of x makes that bracket 0? Well, the value of 3. So if x is 3 and I've got 3 minus 3, which is 0, 0 squared. Okay, so then that whole part of the bracket would disappear and you'd be left with 36. So the turning point then is going to be at 3, 36. Now, say if you're a further mathematician, you're doing further maths GCSE, you could do this by differentiation. You could just find dy by dx and say that, well, that is 18 minus 6x, and then put dy by dx equal to 0 and find x that way. That would be a whole lot easier actually than doing it by completing the square. But that's only if you're doing further maths. I wouldn't recommend learning all this just to make this question easier for yourself. It's not. So just if you happen to be doing further maths and you happen to know what all this is, then you could try that way instead and make your life a little bit easier. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.